There is a star not far from here, as distances in the universe are measured. It sits just over 4 light years away, which sounds like a great span, and in human terms it is, but among the hundreds of billions of stars in our galaxy, it is practically a neighbor. It is called Proxima Centauri. It is small and dim and very old, and circling it, at a distance closer than Mercury circles our own sun, there is a world. That world is called Proxima b. We do not know everything about it. Science rarely hands us complete pictures. What we have instead are measurements, careful ones, gathered over years of patient watching. And from those measurements, we can begin to imagine what it might be like to stand there, on that surface, beneath that unfamiliar sky. So let us imagine it together slowly, with no particular hurry. Picture yourself there. The ground beneath you is not soft. It is rock, dark and old, perhaps volcanic in texture, though we cannot say for certain. The surface of Proxima b is largely a matter of quiet guesswork, informed by what we know of rocky planets in general, and of the star it orbits in particular. You press your foot against it and feel something solid, something permanent, something that has been here for a very long time. The first thing you notice is the light. It is not the light you know. Proxima Centauri is a red dwarf star, meaning it burns cooler and dimmer than our sun, and the light it gives off is shifted toward the red end of the spectrum, well into the infrared range that human eyes cannot detect at all. What reaches your eyes would appear dim and ruddy, something like the last moments of a sunset that never quite resolves, a permanent late afternoon rendered in shades of red and orange and deep amber. The sky itself, if Proxima b has a thick enough atmosphere to scatter light the way Earth's does, might not be blue. It could be reddish. It could be something closer to a dull copper tone, or a kind of ochre that deepens toward the horizon. We do not know for certain whether there is an atmosphere at all. That question remains open, gently open, like a book left on a table with a page still to be turned. If there is no atmosphere, the sky would be black. The star would hang there, larger and closer than our sun appears, but dimmer, burning low and slow like an ember rather than a flame. The stars behind it would be visible even in the daytime, because without air to scatter the light, there is no daytime glow, only the star itself against the dark. Either version has its own kind of stillness. Now consider the rotation, or the likely lack of it. Proxima b orbits so close to its star, completing one full orbit in just about 11 Earth days, that gravitational forces have probably locked one face permanently toward the light. This is called tidal locking, and it is the same reason our moon always shows us one face. If Proxima b is tidally locked, Then one side of this world sits in permanent day, and the other in permanent night. And there is a line between them, a terminator, where the light always arrives at the same low angle, always golden and slanted, like the light of something ending or beginning and never quite doing either. Imagine you are standing somewhere on that boundary. The star hangs low on your horizon always. It does not rise. It does not set. It simply rests there, a dull red eye watching. Time passes differently in a place where the sun does not move. You would have to count it some other way. On the night side, there is nothing but darkness and cold. The cold there would be profound. Without a sun to warm it and without necessarily a thick atmosphere to carry heat from the day side, the night hemisphere might be very cold indeed, colder than anything in human experience. But we say might. Always we say might. On the day side, temperatures could be warmer, perhaps warm enough for liquid water in some narrow band. If the planet is the right kind of rocky world, if it has the right kind of atmosphere, if a great many things align in the right way. Those are many conditions, and we hold them lightly. There might be wind, not the sharp wind of a summer storm, but something steadier and slower, driven by the temperature difference between the eternal day and the eternal night, air moving from the warm side toward the cold in a slow, planetary exhale. If you stood on that terminator line, you might feel it as a constant, gentle pressure against your skin, always moving in the same direction, always the same. The sounds here would be minimal. Rock does not make much sound on its own. If there is no ocean, there is no tide, no wave, no distant water. If there is no thick air, sound itself would carry differently, or not at all. There might be wind, as we said, and with wind there might be a low hiss across stone, a kind of white noise that the ear adjusts to quickly and then stops hearing. In the absence of obvious sound, you begin to notice other things. You notice that Proxima Centauri, that small and patient star, is a flare star. This is something we know with some confidence. Red dwarfs of this type are prone to releasing bursts of energy, flares, sudden brightening that could, in theory, strip away a thin atmosphere over long periods of time, or bathe a nearby surface in ultraviolet radiation. These flares would not be like quiet dawn light, but they would come and go. In the deep time of this world, they have been coming and going for billions of years. And yet here is the world, still here, still orbiting. If there is life somewhere in the universe, it has had longer to adapt to harder conditions than we might have assumed. This thought does not demand excitement. It simply sits there, the way the star sits on the horizon, low and steady and very old. The star itself is older than our sun, or roughly as old, which means Proxima b has been circling it for a long time. The surface has had time to change, to cool and crack and be remade by whatever forces operate here. There is a kind of depth to old worlds that is hard to put into words. They carry their history the way thick stone carries coal, all the way through. You look up if there is a sky to look into. If there is an atmosphere, you might see clouds, or at least the possibility of clouds. On the day side, any water that exists might be cycling slowly, evaporating, moving, condensing somewhere. The clouds, if they exist, would be lit in that reddish light, and they would look nothing like the white piles of cumulus you might know. They would be something warmer in tone, something amber or rust, or the color of old iron. You might stand there for a long time and feel that nothing is changing. That is the nature of a tidally locked world. The light does not shift. The shadows do not move. The star does not track across the sky. Only the slow movement of clouds, if they are there, would give you any sense of time passing at all. And yet everything is still in motion. The planet moves through space. The star burns. Atoms collide and release energy across millions of kilometers. You are standing on a moving thing, a thing in orbit, a thing participating in the slow and enormous machinery of a star system, even if you cannot feel it, even if it all looks still. There is something calming about that. The stillness that is not actually stillness, the quiet that contains so much. Proxima b is, as far as we know, the nearest world to our own beyond the solar system. 4 light years is not close by any practical measure, not in any human sense of travel or time. But in the vast context of space, it is next door. It is the first address on a very long street. If we ever learn to send something across that distance, a signal, a probe carried on a beam of light, a message, this is where it might arrive first. This quiet, rocky, dimly lit world hanging in its endless 11-day circle around a small red star. We have already sent signals toward it in a way. Radio waves move outward from Earth constantly, spreading in all directions, growing fainter as they go. Some of those waves have already passed Proxima b. They have continued on into the dark beyond. We do not know what, if anything, received them. And so Proxima b remains, as it has always been, largely beyond our reach. We observe it from a great distance, measuring the tiny wobble it induces in its star, calculating its mass, estimating its orbit. We do our careful mathematics. We build our careful models, and then we let ourselves imagine just a little what it might be like to stand there on that old dark rock, under that low red light, in that quiet that may or may not have air moving through it. It is the nearest world we do not know, the first of many such places, circling their distant fires, keeping their own particular silences. For now, it is enough to simply picture it. The horizon flat or gently curved, the star unmoving, the ground beneath you ancient and still, the possibility of wind, the possibility of nothing at all. Just the planet patient in its orbit, just the star burning slow. The star is small. That is the first thing you would notice if you were standing on the surface of this world. Not the color, though the color is striking in its own quiet way. Not the temperature, though the air here is cool and still. The first thing is the size. TRAPPIST-1 hangs in the sky roughly twice as wide as our own sun appears from Earth, and yet it gives off so little light that the sky around it settles into something closer to a deep, perpetual dusk. It is a red dwarf, one of the most common kinds of stars in the galaxy, and it burns with a patience that is difficult to imagine. This star has likely been shining for billions of years already, and it will continue to shine for trillions more, long after our own sun has grown and dimmed and gone quiet. Stand here and look up. The star is the color of an ember, or of the last traces of sunset seen through a thick atmosphere. Not orange exactly, more of a dark, muted red. There are no clouds today. The sky around the star is not blue in the way you might expect. The scattered light here bends toward longer wavelengths, and so the sky tends toward something softer, a reddish ochre near the horizon, deepening into a muted burgundy toward the zenith. There may be stars visible even during the day, depending on how thin the atmosphere is and how far you are standing from any source of reflected light. This world, TRAPPIST-1e, is one of 7 planets orbiting this small red star. 7. All of them roughly the size of Earth, all of them packed into an orbital system so compact that every single one of them could fit within a distance shorter than the distance between Mercury and our Sun. They orbit close, very close. TRAPPIST-1e completes its year in just over 6 of our Earth days. And yet, despite that closeness, the star's light is so dim that this planet sits comfortably within what astronomers call the habitable zone. The temperatures here may allow liquid water to exist on the surface. We do not know for certain. The atmosphere is still largely a matter of careful, ongoing study. But the conditions, as best we can estimate them, are not hostile in the ways that immediately come to mind. Imagine you are drifting across a flat, open plain here. The ground beneath you is dark, possibly volcanic in composition, covered perhaps in low, wind-smoothed stone. There is a wind, gentle and constant, moving from one direction in a very deliberate way. This world is almost certainly tidally locked to its star, the same face always turned toward the light, the way our moon always shows us the same side. If you are standing on the sun-facing hemisphere, the star does not rise or set. It simply rests in its fixed position, always there, always glowing, like a lamp left on in a room where no one moves. The wind, then, is a consequence of this arrangement. Heat accumulates on the day side and the atmosphere tries, slowly and without urgency, to carry that warmth around toward the night side. The circulation patterns on a tidally locked world are unlike anything we experience on Earth. There are no seasons in the traditional sense. There is no dawn chorus, no long summer evening. There is only the eternal face of the star and the slow turning of heat into wind. If you walked far enough in one direction, you would eventually cross into the terminator, the line between eternal day and eternal night. This is a region that some researchers find particularly interesting. A ring around the planet where the sun sits permanently near the horizon, always setting, never quite set. The temperatures here might be moderate, the light always arriving at a low angle, always the color of late afternoon. If liquid water exists on this world, and if conditions are right, the terminator region is sometimes imagined as one of the more hospitable places to be. The night side on the other side of that line is cold and dark. The star does not appear there at all, but the sky above the night side would be something quietly remarkable. The other 6 planets of this system would be visible from the surface on clear nights, some of them appearing as distinct disks rather than simple points of light. They are that close. Imagine watching one of them cross slowly overhead, a pale circle against the stars, its own surface faintly lit by the dim redness of the shared star. The star itself produces flares. This is one of the genuinely uncertain things about TRAPPIST-1. Red dwarf stars are often more active than they appear, prone to bursts of ultraviolet and X-ray radiation that can be more intense than those from larger, brighter stars. TRAPPIST-1 has been observed producing such flares. What this means for life, or for the atmosphere, depends on many factors that are not yet known. A thick enough atmosphere, or a magnetic field, or simply the chemistry of the surface, might absorb or deflect what the star sends out, or it might not. We hold that uncertainty gently. It does not close the door. It simply leaves it ajar. For now, imagine a quiet afternoon on the day side, the star where it always is, the wind moving across the stone, the sky its slow red above you. The light is not bright. You could look in the direction of the star without it being comfortable. It is still a star, but the quality of the illumination here is different from what you might experience under a yellow sun. Shadows here are dark and deep because there is less scattered light to soften them. Colors that rely on blue wavelengths might appear muted or absent. Red and orange and brown would look as they always do, but something like a green leaf, if such a thing existed here, might seem slightly different, slightly off. The way colors can look under certain artificial lights. There is something interesting about how our eyes would need to adjust to this place. Not to darkness exactly, but to a different kind of light. We evolved under a yellow star, and we carry that in our perception. The light here would feel dim even when it wasn't, the way a quiet room can feel empty even when it is full of still things. The sounds here are a matter of speculation. If there is an atmosphere of roughly Earth-like density, then wind would carry sound in familiar ways. The pressure of air on stone, the movement of whatever might exist on this surface, would all propagate at familiar speeds. But we do not know what sounds this world makes. Perhaps only wind over stone. The low, continuous breath of a planet trying to balance itself between light and cold. Seven planets around one small star. There is something almost architectural about it, the way they are arranged so precisely, each in a gravitational conversation with the others. The orbits of TRAPPIST-1's planets are locked in what are called orbital resonances, mathematical relationships between their periods, so that certain planets complete certain numbers of orbits in the same time others complete different numbers. It is a kind of order that persists across billions of years, the way a slow, deep song can hold its rhythm without effort. Standing on TRAPPIST-1e, you could watch the other planets with patience. They move across the sky at their own careful speeds. TRAPPIST-1d, closer to the star, moves faster. TRAPPIST-1f, farther out, moves more slowly. They are not stars in the sky. They are worlds, identifiable as worlds, with apparent sizes that remind you of this system's unusual compression. How much has been arranged in such a small space? We found these planets in 2017, though the star had been known before that. The discovery was made using a telescope in Chile, and later confirmed with observations from space. The method was transit photometry, watching the star's light dim in tiny, regular increments as each planet passed in front of it. The dimming is small, fractions of a percent, but it is regular, and regularity is a language that science learns to read. Seven signals in the starlight, each one a world. TRAPPIST-1e was identified as one of the most promising of the seven in terms of the potential for surface water. Not because we detected water, we have not yet, but because the energy it receives from its star, accounting for the star's luminosity and the planet's distance, places it in a range that models suggest might be compatible with liquid water under a range of atmospheric conditions. Compatible is the word, not certain, not confirmed, compatible. And that is enough for now. To stand here in imagination and feel the cool, still air, and watch the dim red star hold its position in the ochre sky, and listen to whatever the wind carries across this ancient, quiet surface. The star will not move. The night side will remain dark. The other planets will complete their short orbits and come back around again. This is a place of repetition, of patterns worn smooth by time, of a system that has been doing the same things for longer than our solar system has existed. There is something restful in that, in the idea of a sky that does not change, of a star that simply stays, of a planet going about its long, quiet business without hurry. You could rest here if you let yourself. The wind is gentle, the light is soft, the star asks nothing of you. It simply shines as it has always shone, small and steady and patient, in its place in the sky. Some worlds are not places you could stand. Not because they are too far or too strange in some abstract way, but because the ground itself would not hold you. The surface, if you could call it that, would be moving. Slowly, perhaps, by some measures, but moving nonetheless, bright and viscous and hot beyond easy imagining. "55 Cancri E is one of those worlds. It orbits a star about 41 light-years from here, in the constellation Cancer. The star itself, 55 Cancri A, is a little older than our Sun, a little cooler, a little more orange in its light. From Earth it is just barely visible to the naked eye on a clear night, a faint point that most people have walked beneath without knowing it. And circling that star, so close that a year lasts less than 18 hours, is this world. A world roughly twice the diameter of Earth and about 8 times the mass. Dense, close, hot. So hot that the rocks have likely melted. Let the thought arrive slowly. There is no need to rush it. You are thinking about a planet where the temperature at the surface may reach over 2,000 degrees Celsius, where silicate minerals, the kinds of minerals that make up basalt and granite and the dust on mountain paths, have passed through some threshold and become something else. Liquid, a kind of magma, spreading and slow, covering what would otherwise be ground. There may be an ocean here, just not one made of water. Some researchers have proposed that parts of the surface of 55 Cancri E could be covered in an ocean of lava. Not a river, not a flow, but an ocean. Vast, dark in places where it cools very slightly at the edges, glowing amber and orange and pale yellow toward the center, moving with a kind of slow tide, pulling toward the star that holds this world so close and so tightly. Imagine you are drifting above it, at some safe and impossible remove. The light is strange. The star is large in the sky, much larger than our Sun appears from Earth, because the planet is so near, only about 2.5 million kilometers from its surface. That closeness means the star does not look like a point. It looks like a presence, a warm amber disk taking up a significant portion of the view, spilling light that falls not blue-white, as sunlight can seem to us, but golden, slightly orange. The color of late afternoon stretched across all hours at once. There are no hours here, in any ordinary sense. "55 Cancri E is likely tidally locked, the same face always turned toward its star, the way our moon always shows us the same side. One hemisphere in permanent day, one in permanent night. The boundary between them, the terminator line, would be a place of strange gradation, not a horizon that moves, a permanent edge where the light stops and the dark begins." The day side glows. Not just from the star above, but from the ground below. The surface, or what passes for surface, emits its own light. A deep red, a pale amber, the colors of forge fire seen from a distance. It is not the kind of light that illuminates. It is the kind of light that emanates. Everything here is a source of warmth, a source of that low red glow. The atmosphere, if there is one, is uncertain. Early observations suggested 55 Cancri E might have a substantial atmosphere, perhaps one rich in gases driven off from the molten rock below, carbon dioxide, sulfur compounds, silicon vapor rising from that slow lava sea. Later observations complicated that picture. There may be something thin and shifting above the surface, outgassed from the rock, not constant, not stable, not the kind of air that persists the way a planetary atmosphere usually does, but more like a breath, drawn out of the land by heat and lost again into space. If there is any sky here, it may be hazy. Think of the way a fire at a great distance looks through warm air. The shimmer, the slight blurring at the edges. Something like that, perhaps, rising from the surface of this world and softening the view of the star above. Not clouds in the way we think of clouds. Not water vapor gathering into shapes and moving in wind. Something heavier, slower. A mineral haze. Sound would carry strangely, if at all. On Earth, sound travels through air, through pressure differences, through the ordinary stuff of our atmosphere. Here, what atmosphere exists is so uncertain, so thin in places, that the idea of sound becomes theoretical. If you could stand at the edge of that lava ocean, not on it, but somewhere near its shore, and something moved in that slow molten surface, you might perceive a vibration. A low tremor through whatever ground remained solid enough to hold. Not a sound exactly. More like a presence, transmitted through the soles of the feet. Everything here communicates through heat, and light and pressure. The night side is a different silence. Tidally locked worlds often develop extreme temperature differences between their two faces, and 55 Cancri E is no exception. The night side, perpetually turned away from the star, may be dramatically cooler than the day side, though cooler here is still relative. Even on the dark face, temperatures would remain extreme by any human measure, but the glow would fade. The amber light would dim. The horizon, if you were moving toward it from the day face, would grow darker by degrees, and eventually you would find yourself in something approaching actual shadow. Perhaps the lava solidifies there, at the edges. Perhaps in the deep night of that permanent hemisphere, the molten material that flows so freely in the light has cooled to something more solid, a dark crust, glassy and black, like the basalt that forms at the edges of lava flows on Earth when they meet the ocean. There is something oddly quiet in that image, all that heat and motion, finally coming to rest in the dark. The word that keeps returning, thinking about this world, is wait. Everything about 55 Cancri E suggests density. The planet itself is dense, more so than Earth in its composition. The gravity would be stronger. The star pulls it with tremendous force. The rocks have been pressed and heated to the point of flowing. Even the light seems heavy here, the amber light of an older, cooler star falling onto a world that has no distance from it, no room to breathe. And yet there is something in it that is not violent exactly. Violence implies sudden change, impact, rupture. What happens on 55 Cancri E is slower than that. The melting of rock is a patient process. Lava moves at the pace of something that is not rushing. It simply goes where gravity and heat direct it, without hurry, without decision. If there is an ocean of it here, that ocean has perhaps been there for a very long time, cooling at its edges, being replenished by new material from below, finding its own level, the way all liquids do, across a world that has been close to its star since the beginning. There is a kind of steadiness in that. The data that tells us about this world comes from light. From the way 55 Cancri E dims the star's brightness ever so slightly as it passes across its face, and from the way the star's spectrum shifts almost imperceptibly as the planet moves. Humans determined all of this from instruments pointed at a faint point in the sky. The surface, the glow, the possible lava ocean, all of it is an interpretation, a careful and well-reasoned one, built from light curves and spectral analysis, and the long work of many people comparing what they observed to what physics suggests should exist. It is worth pausing on that. 41 light years is a distance that does not reduce to anything familiar. The light leaving 55 Cancri A right now will reach Earth in 41 years. And yet the light that already arrived, that we have already collected and studied, has told us enough to imagine this. To place ourselves, however speculatively, above that amber glow, watching a star that fills a significant part of the sky. This is not a world that invites you. But it does not need to. Some places exist entirely outside the category of hospitable, and there is no judgment in that. This world is doing what it has done for billions of years, orbiting, glowing, losing small amounts of its possible atmosphere to space, being slowly, imperceptibly reshaped by the forces that act on it. It has no relationship with the idea of welcome or unwelcome. It simply is. And knowing that it is, knowing that right now, this very moment, somewhere in the direction of Cancer, a small, dense world is moving through its short year in the fierce light of its star. Its surface a slow amber sea, its sky full of that heavy orange glow, its night face cooling gradually to something dark and glassy and still. That knowledge is, in itself, a kind of quiet thing. Something to carry gently. Not with excitement, not with urgency, but with the same low patience the lava carries as it finds its level, as it has always found its level, on a world that is both nothing like home and, in its own way, entirely unremarkable. Just another planet doing what planets do. Glowing slowly in the dark. There is a place, not so far in the scale of things, about 63 light years from where you are now, where the wind blows at speeds that have no comparison in ordinary experience. Not because that is frightening, but because it is simply what the atmosphere does there, the way water does what water does, following the rules it has always followed, indifferent to whether anyone is watching. HD 189,733b. You can hold the name loosely. It does not need to be memorable. The planet itself is what matters, turning slowly in your mind like something seen through deep water. It is a gas giant, a world with no solid ground, no place to stand in any ordinary sense. But imagine you are drifting, not falling, just suspended somewhere in the upper layers of its atmosphere, where the pressure is something like what you might feel near the surface of our own ocean, and the temperature is already more than 1,000 degrees. This is simply where the air begins. The color of the sky here is thought to be blue, a deep, saturated cobalt blue, the kind of blue you might find at the edge of twilight back home. But everywhere, in every direction, unrelieved by anything lighter. Scientists believe this color comes from tiny silicate particles suspended in the upper atmosphere, particles that scatter blue light and absorb other wavelengths. The blue is not comforting in a warm way. It is cool and even an ancient failing, like the inside of something that has been sealed for a very long time. There is no sun to look at directly here, not because there is no star, but because HD 180-9733b is tidally locked, its rotation and its orbit synchronized, so that one side always faces its orange star, and one side always faces away. The planet circles very close, about 4% of the distance between Earth and our Sun, completing one full orbit in about 2 of our days. The star is large and warm in the sky above the day side, far larger in apparent size than our Sun appears to us, filling a significant portion of the horizon. But you are not on the day side. You are somewhere near the boundary, the terminator, where the permanent day and the permanent night meet in a slow and unmoving twilight. Here at the edge, the light is oblique and orange tinted, the kind of light that feels like late afternoon even though it is always this, always exactly this. The star hangs low and does not move. It does not rise and it does not set. It simply rests there, enormous and orange, casting long shadows that never change, illuminating the upper layers of cloud in warm tones that fade quickly as you drift toward the dark side. The wind is what you would notice most, if noticing were still the right word for something so total. Wind speeds on HD 180-9733b are estimated to reach somewhere around 5,000 miles per hour, perhaps more. This is not a gust. This is not a storm in any sense we have language for. It is more like the atmosphere itself is a single continuous motion, a vast and perpetual river of superheated gas moving from the day side to the night side and back again, trying to equalize temperatures that can never quite be equalized. You would not feel it the way you feel wind. You would simply be part of it. The sound, if sound could travel clearly through such dense and pressurized gas, would probably not sound like anything sharp. Not a howl, not a roar in the way we imagine those things. More like a low, continuous pressure. Something felt in the structure of whatever is doing the feeling, more vibration than noise, more presence than event. The clouds here are not water. They are not ice. They are made of silicate particles, tiny fragments of what is essentially glass, blown and suspended and carried in currents that never stop. When scientists describe rain on HD 180-9733b, they describe silicate particles, glass, condensing in the upper atmosphere and falling briefly, before the wind catches them again and carries them sideways, upward, back into suspension. It is not rain the way rain falls on a still evening. It is more like the glass is simply part of the wind, inseparable from it, drifting and tumbling without any real direction called down. There is something almost quiet about imagining it this way. Not quiet in volume, but quiet in the sense that there is no urgency to any of it. The glass has been falling for a very long time. The wind has been blowing for a very long time. The star has been sitting in the same position in the sky, enormous and orange, for longer than any human framework of time helps to understand. Nothing here is rushing toward anything. The night side of the planet is cold by the standards of a hot Jupiter, though still hundreds of degrees by our standards. The transition between the two hemispheres drives everything. All that wind, all that suspended silicate. The atmosphere is constantly attempting something like equilibrium and constantly failing to reach it, circling instead in a stable kind of turbulence, a permanent dynamic that looks like chaos but repeats and repeats with the same patterns. We know this planet as well as we know almost any exoplanet. It was one of the first to have its atmosphere studied in detail. We know the blue color from data. We know the wind speeds from models refined against careful measurements. We know the temperature difference between the day side and the night side. We know there is water vapor in the atmosphere and carbon monoxide, and traces of other molecules carried in that endless current. Knowing these things does not make the place feel less strange. If anything, the specificity makes it stranger. The way knowing the exact shade of blue in a painting makes the painting more precise, and therefore more itself. The blue would be everywhere. Overhead, in the direction you might call east or west, though those directions mean something different here. Blue, the blue of silicate scatter, the blue of a sky that has settled into this color the way water settles into the shape of whatever holds it. Below you, if below is meaningful, the atmosphere deepens and thickens and warms toward pressures that would compress anything fragile down to nothing. Above you, the gas thins toward the edge of the planet's gravity, where some of it is actually being lost to space, slowly, year by year. A thin comet-like trail of atmosphere streaming away from the star's radiation. Even that is slow. Even that loss is geological in pace, a leak that takes millions of years to matter. There is no silence here in the way we usually mean silence, but there is a kind of sameness that functions like silence. The wind does not change. The star does not move. The blue does not shift. If you let yourself stop expecting change, the constancy begins to feel like stillness, the way a single sustained note, held long enough, stops sounding like a note and starts sounding like quiet. You would lose track of time very quickly here. Not because time is distorted in any relativistic sense, but because time is measured by change, by the sun's position, by the arrival of weather, by the alternation of dark and light, and none of those things change here. The star stays where it is. The wind blows exactly as it was blowing. The glass continues to fall sideways through the blue air. If you drifted toward the day side, the temperature would rise quickly. The light would become more direct, the star filling more of the sky, the upper clouds lit in harsh orange. If you drifted toward the night side, the star would shrink below the horizon, and the sky would become a different kind of deep, still blue-black, lit by the reflected light of the day side bouncing off the cloud tops on the edge. Neither direction is more hospitable than the other. Both are simply different arrangements of the same elements. The star that this planet orbits is a K-type star, slightly cooler and smaller than our Sun, with an orange warmth to its light that would give everything a particular cast, less harsh than our Sun's white-yellow light, more amber, more autumnal in a way. The star is also somewhat variable, prone to occasional outbursts of energy, flares that wash over the planet's already heated atmosphere without, apparently, dramatic effect. The atmosphere simply absorbs and continues. There is something in that, in the way the planet's atmosphere simply absorbs and continues, that is worth sitting with for a moment. Not as a lesson, not as something to carry back into ordinary life, just as a thing to notice, in the same way you might notice the way water in a glass settles after being disturbed, returning to its level, holding its surface still. The blue world turns, or rather does not turn, suspended in its locked position around an orange star 63 light-years away, and the glass moves through the air, and the wind carries everything it carries, and the atmosphere loses a little of itself to space, very slowly, as it has for longer than our species has existed. It does not need to be anything more than what it is. Somewhere in the upper layers of that blue, in the oblique orange light of the Terminator, things are drifting that have been drifting for a very long time. You can rest in that for a moment. The constancy of it. The way it continues without needing anything from anyone. Just blue and wind and glass, and the same star in the same position, and the slow loss of something into space, grain by grain, year by year, unhurried and without regret. There is a planet, about 200 light-years from here, where the concept of a single sun would be genuinely difficult to explain. Not because the people there could not understand it. There are no people there as far as anyone knows, but because the sky itself, for as long as that planet has existed, has always contained two stars, one orange, one red, both present, both casting light at angles that shift and cross and sometimes, briefly, overlap into something neither of them is on their own. Kepler-16b, it orbits both of them. Imagine you are standing on the surface of that world. The ground beneath you is cold. Not the cold of a winter morning, but the cold of a place that receives, on average, less warmth than it needs to feel comfortable to anything like us. The temperature, best estimates suggest, sits somewhere well below freezing. The kind of cold that settles into stillness, that does not move or announce itself. That is simply the ambient condition of the place. You would not feel the wind because there may not be much wind. The composition of the atmosphere, if there is one in any meaningful sense, remains uncertain. This is not a world we have walked. It is a world we have inferred, measured by the way it dims two stars at once, detected at a distance by its shadow rather than its light. And yet the shadow tells us something. The planet is a gas giant, or close to it, roughly the mass and radius of Saturn, though not Saturn. Nothing out here is a copy of something closer. It takes a little over 200 days to complete one orbit around both stars together, tracing a wide path that keeps it clear of the close dance the two stars perform around each other. Those two stars orbit one another in a period of about 41 days, which means if you were somehow suspended above this world and watching the sky, you would see the stars in different positions each day, different separations, different intensities of combined light. The geometry of their relationship always in slow, patient motion. The sky over this place is never quite the same 2 days running. The orange star is the larger of the two. It is close to the mass of our sun, but a little cooler, a little dimmer, casting a light that tends toward amber rather than the white-yellow of midday in summer. The red star is smaller, noticeably so. It contributes its own wash of reddish light, much fainter, but present, adding something to the shadows that a single sun would never produce. Shadows here, if shadows exist to fall on anything solid beneath the gas, would be complicated. Or rather, they would be doubled, then merged, then doubled again as the two stars moved across the sky relative to each other. There would be directions in which the light came from two places at once, and other directions where one star temporarily disappeared behind the other, and for a short time the light would simplify. It would not be darkness, just a reduction, a narrowing. Try to picture the color of that sky during a moment of transit, when the smaller red star slips across the face of the larger orange one. The light falling changes its mixture. The orange deepens, perhaps. The red note in it becomes more prominent for a little while, and then the red star emerges on the other side, and the light opens back out again into whatever passes for normal here. There is no one on this planet counting the transits, marking the days. Nothing is waiting for the light to return. The light comes and goes, and the planet continues along its orbit, indifferent in the way that all very cold, very distant things are indifferent. The surface, if you could reach it, is almost certainly not solid. You would not stand on Kepler-16b the way you might stand on a rocky world. You would descend into it, through layers of gas that thickened gradually, through pressures that increased slowly, and eventually into something dense enough to feel like substance without ever quite resolving into ground. This is worth sitting with for a moment. The idea of a world you cannot stand on. A world that has no edge between surface and atmosphere, only a long gradation from thin to thick, from cold to less cold, from open to dense. And yet it orbits its two suns. It has mass and gravity, and a path through space it follows with great consistency. It is a world in every meaningful sense. The two stars, from the perspective of this planet, would not always be visible at the same time. Depending on where Kepler-16b is in its orbit, one might have set while the other is still climbing, or both might be in the sky together at shallow angles, their combined light spread across the upper clouds in something warm and layered. A double sunrise of a kind. The orange star appearing first, perhaps, brightening the sky from one direction, and then the smaller red one following, adding its quieter note. Or they might rise nearly together on some mornings, close enough in the sky that their light blends before either of them has fully cleared whatever horizon exists in the deep and turbulent upper atmosphere. Sunrise here is not a single event. It is a sequence, or sometimes a chord. The clouds in the upper atmosphere, if they exist in forms we could recognize, might be colored by that light in ways that are hard to imagine from here. The high cirrus of a gas giant on our side of the galaxy catch the sunlight at dawn and turn pink and gold. Here the incoming light has two sources with two temperatures, and the colors they cast on ice crystal or ammonia haze might be something in between, something that does not have a name in any language we use. Not dramatic, just different. The way that a different mixture of minerals turns a canyon red in one place and pale cream in another. Chemistry and light, at work for a very long time, producing a result that is simply the result. If you drifted in the upper atmosphere here, in whatever medium occupies that layer, you would perhaps sense the slow churn of large weather systems moving beneath you and above you. Gas giants move in bands, in jets, in enormous slow rotations that span thousands of kilometers. The winds in those bands can be very fast, but from inside a system that large, the motion feels more like drifting than rushing. You would not hear the wind in any way that meant something. There is no one to hear it. The sound would travel through whatever medium surrounds you and arrive at nothing, pass through nothing, dissipate into the general quiet of the place. Most of the universe is like this, present and moving and completely without an audience. The orbit Kepler 16b follows around its two stars is, as far as anyone can tell, stable. It has been stable for a long time. The two stars have been dancing around each other since before the Earth had oceans, and the planet has been following them in its wider circle for much of that same duration. Stability in a system like this is not guaranteed. The gravitational mathematics of three bodies, two stars, and a planet can become complicated in ways that introduce drift and change over long periods. But so far, in all the time this system has existed, the orbit has held. The planet goes around. The stars go around each other. The light falls. There is something in that persistence. Not comfort, exactly. More like the feeling of a very long note held very steadily. At some point in the orbit, the planet moves between us and one of the stars, or one star moves between us and the planet, and the signal dims slightly in our instruments. This is how we know it exists. This is how we know its size, its orbit, the period of the binary stars. A small, repeated dimming, detected by a telescope pointed patiently in that direction, recorded and studied and eventually understood. The planet did not announce itself. It simply passed in front of a light, as things do, and the light changed briefly, and someone was watching. It is strange to think about what we know and how we know it. The entire understanding of this world, its size, its orbit, its distance, its temperature, all of it comes from measuring the way it blocks light. We have not touched it or heard it or smelled it or held any piece of it. And yet it is real as the ground beneath us here, as real as the cold of a winter window, as real as the distance between two people in a quiet room. Real things do not require our presence to be real. Somewhere around that binary star system, in an orbit that takes roughly 229 days to complete, a cold and heavy world turns slowly through its sky of two suns and deep cloud, and whatever quiet occupies the space between its upper atmosphere and the stars. The orange one is brightest. The red one adds its note. They move around each other with the patience of things that have been moving for billions of years. The planet follows. The light falls on cloud. The cloud is there or it is not, and either way the planet continues along its path, through the doubled and shifting light of two stars, through the cold, through the long and unobserved passage of time, around and around and around. There is a world not far in the scale of things, orbiting a small red star about 40 light years from here. It is called, in the way we name such places, GJ 1214b. The name is a catalog entry, a librarian's notation, and it tells you almost nothing about what the place is like. What we think it might be like, though, is something worth sitting with for a while. It may be a world made almost entirely of water. Not water the way we mean when we say ocean. Not a blue shallowing thing with a sandy floor somewhere beneath. The water on this world, if our measurements are right, would go down for a very long time. There may be no bottom in any ordinary sense. The pressure at depth would be extraordinary, enough to compress water into forms that behave like neither liquid nor ice in the way we understand those words. Somewhere far below, if below even has meaning there, water may exist in phases that have no name in any human language, only in physics. Imagine you are drifting just above the surface. The surface would not be dramatic. That is one of the quieter things about it. There would be no visible boundary between the ocean and the sky in the way you might expect. No clean horizon line where blue meets blue and you can feel the openness of it. The atmosphere of GJ 1214b is thought to be thick, possibly rich in steam and heavier gases, and whatever light arrives from its star would diffuse slowly through that weight before reaching anything you might call the surface. The quality of the light would be muted. It would feel less like standing in sunlight and more like standing inside something. The star itself is a red dwarf, small and cool and ancient in the way red dwarfs are ancient. It puts out far less light than our sun, and most of what it emits leans toward the red and the infrared, the long, slow wavelengths. To eyes adjusted to our own sky, this star would look dim and deeply colored, something between a coal ember and a harvest moon, hanging in a sky that does not quite brighten the way you are used to. Day would feel more like a long, soft dusk. Not dark exactly, but never fully lit. GJ 1214b orbits very close to this star. Its year is only 38 hours long. It completes an orbit in less than 2 of our days. At that distance, it is almost certainly tidally locked, meaning one face of the planet always turns toward the star, and the other faces permanently away. There is a side in perpetual dim warmth, and a side in perpetual night, and a region between them, a long curved band of terminator, where the light falls at a low and constant angle, and the temperature sits somewhere between the two extremes. If you were drifting above the dayside ocean, the star would be fixed in the sky. It would not rise or set. It would simply be there, always in the same place above the horizon, reddish and steady, illuminating the water below with the same patient, unchanging light, hour after hour, year after year. There is something both peaceful and disorienting about that image. The sky that never changes, the star that never moves. The water below would not be still. Even without a moon pulling at the tides, even without the rhythm of day and night to drive atmospheric cycles, there would be movement. Convection would carry heat from the day side toward the night side, currents circulating slowly through that immense depth, and at the surface there would likely be wind. The atmosphere would circulate too, though how exactly is difficult to say. What we know from our models is that something moves. The ocean, the air above it, the water vapor rising in slow columns from the warmest parts of the surface. It would be a quiet kind of weather, most likely, but weather nonetheless. The clouds, if there are clouds, would tell us something important. In fact, they already have. When astronomers observed GJ 1214b passing in front of its star, they measured how different wavelengths of light filtered through the planet's atmosphere at the edges. A clear atmosphere, or one with certain kinds of gas, would have left a particular fingerprint. What they found instead was a spectrum that was, in the technical language, flat, featureless, which means something was blocking the view. Something uniform and high in the atmosphere was preventing the light from reaching down far enough to pick up the signals of whatever lay beneath. Clouds, most likely, or a thick haze. So the sky above that ocean may be overcast. Not dramatically overcast, not the dark rolling ceiling of a storm, but a high and even layer of cloud or haze, the kind that softens everything, that makes the light come from everywhere at once rather than from a single direction. The kind of sky where you cannot quite find a shadow. On that tidally locked world, the clouds would likely be distributed in a pattern shaped by the fixed position of the star, thicker perhaps where the heat is greatest, thinning toward the terminator, absent or different on the night side. But above the dayside ocean, you might stand or float in a diffuse and pinkish light, the star invisible behind its veil, the air warm and still and heavy with vapor. The ocean itself, under that sky, would have no particular color. Color in the end is reflected light, and the light here is not the light you know. Whatever blue we associate with Earth's oceans comes partly from the sky above it, partly from the scattering of light within the water itself. Here, with a redder star and a thicker sky, the water might look gray, or it might carry a quality that has no easy name, something between rust and pewter, shifting slightly as the clouds moved overhead. It would not be ugly. It would simply be different in the way that most things, seen clearly, are different from what we imagined. And beneath it, all of that depth. There are theories, careful and modest ones, that GJ 1214 be formed farther out from its star than it sits now, in a region of the early solar system where ice was plentiful. As it migrated inward over millions of years, that ice warmed, and the water that makes up a significant fraction of the planet's mass came to cover everything. Some models suggest the water layer could be hundreds of kilometers deep. Others suggest more complex layering, with different phases of water and ice, and possibly rock somewhere far beneath. The details are genuinely uncertain. The planet has not yet told us everything. What it has told us is that it exists. That seems like a small thing to note, but it is not. 40 light years away, a world about 2.5 times the size of Earth moves around a quiet red star once every 38 hours, and it has been doing this for a very long time. Long before anyone was here to calculate its transit timing or wonder about the nature of its atmosphere, it was already there. The ocean was already dark, or lit, depending on the phase. The haze was already drifting. The water was already pressing down on whatever lies beneath. Imagine you are drifting in that atmosphere, not on the surface but suspended some height above it, in the haze layer itself. The light here would be even more diffuse. Below you, the ocean would be invisible, hidden by the same haze you float in. Above you, nothing more visible, only more of the same dimness. You would have no horizon, no up or down that means anything. The air would be warm and wet, not unpleasant, simply thick. There would be no wind you could feel, perhaps, just the very slow movement of air circulating toward the night side. A drift too gradual to register as anything more than a slight pressure, a leaning. Sound, if there were sound, would be absorbed by that density. A word spoken here would not carry far. The ocean below, if it moved at all in the way oceans move, would not be audible from this height. Whatever sounds this world makes, it likely makes them quietly. There is something in that image worth resting with. A world that is almost entirely water, orbiting close to a dim red star, wrapped in haze, existing in a kind of muffled and perpetual twilight, neither loud nor silent, neither dark nor bright. It does not ask to be understood. It simply continues. We have not sent anything to GJ 1214b. We have not taken a photograph of its surface, have not sampled its atmosphere directly, have not even resolved it as anything more than a dimming in a light curve, a subtle change in how bright its star appears over time. Everything described here is inference, the careful and honest work of people reading signals and building models and saying, this is what seems likely, given what we know. That honesty is worth holding on to. The uncertainty is part of the picture, not a failure of it. Somewhere 40 light years from where you are right now, a world covered in deep water drifts through its short year. The haze sits above it. The red star does not move from its place in the sky. The water below does not know it is being imagined. It does not need to. It is simply there, doing what water does under pressure, under low red light, in the quiet of an ocean that has no shore. There is a planet that is disappearing. Not quickly, not in any way you would notice if you watched for a lifetime or many lifetimes, but slowly, over millions of years, it is being drawn apart, its outer layers streaming away from it in a long, continuous exhale toward the star it orbits. Its name is WASP-12b, and it lives very close to its sun. Closer than any planet in our own solar system comes to ours. Imagine you are somewhere above it, drifting. Not on the surface, not exactly, because the surface of WASP-12b is not a place in the way we usually mean. It is a gas giant like Jupiter, composed mostly of hydrogen and helium, and beneath whatever outermost layer you might call a boundary, there is only deeper gas, thicker pressure, temperatures that would unmake anything we have ever built. But imagine you are drifting in those upper layers, in the outer atmosphere. The sky here, if we can call it that, would be a color that is difficult to describe. WASP-12b absorbs nearly all of the light that falls on it. It reflects very little back. Astronomers have measured this and found it to be one of the darkest known planets, darker than coal, darker than fresh asphalt on a warm road. If you were somehow suspended in those high clouds looking outward, the light around you would be swallowed rather than scattered. It would feel less like standing in a place and more like being inside something. And yet the star would be there. WASP-12, the star this planet orbits, is a yellow-white star somewhat larger and hotter than our own sun. From the distance of Earth, it would look something like a bright point among others. But from WASP-12b, it would fill a large and overwhelming portion of the sky. Not because it is an unusual star, but because this planet is extraordinarily close to it. The orbital period of WASP-12b is just over 1 Earth day. It completes 1 full year in roughly 26 hours. It is so close that the star's gravity has begun to pull it apart. This is called tidal disruption, and it is gentle in the way that geology is gentle. It happens across spans of time that resist imagination. The tidal forces stretching WASP-B are the same kind of force that causes our own moon to raise ocean tides on Earth. The same quiet pull that makes the seas rise and fall on their long daily schedule. On WASP-12b, those forces have been working for a very long time on something that has no solid form to resist them. The planet has been stretched into something slightly elongated, its shape no longer quite spherical, pulled subtly toward the star as if leaning into it. Gas from the upper atmosphere drifts away continuously and flows toward WASP-12. It forms a diffuse envelope around the whole system, a kind of shared atmosphere between the planet and its star. Astronomers have described this envelope, this blurred boundary where planet ends and something else begins. There is no sharp edge. There is just a gradual becoming. You would not see this from within it, not clearly. You would perhaps notice a faint luminosity somewhere above you, the gas lit from below or from within by the heat that this planet generates. WASP-B is hot. Its dayside temperature is estimated at around 2,700 degrees Celsius, which is hotter than many stars' surfaces. It is hot enough that its atmosphere may contain vaporized iron and other metals suspended in the upper clouds. The wind on the day side would carry things we usually think of as solid. But there is no day and night on WASP-B as we know it. It is tidally locked. One side of the planet always faces the star, always in permanent exposure. The other side faces permanently away, into the dark of space. The boundary between them, the terminator line, is a long and gradual region of permanent twilight, a place where the star is always on the horizon, always neither risen nor set. Imagine drifting in that region, in the slow borderland. The star would sit low and enormous at the edge of your perception, neither moving nor changing. The light coming from it would not be like morning light or evening light as we know those things, because it would not be transitioning into anything. It would simply be there, permanently angled, permanently golden and white and large. The temperature at that boundary would be somewhat lower than the day side, though still far beyond anything survivable. But in terms of pure sensation, the quality of light at a terminator, that long edge of eternal dusk, is something astronomers sometimes note as beautiful in a strictly geometric sense. Still fixed, enormous. On the night side, there would be almost no light at all. WASP-12b absorbs so much of what reaches it that even with a star so close, the dark side of this planet would be profoundly dark. Somewhere in those permanent night clouds, Temperatures drop considerably, though they remain high by any comparison we might make to cold places we know. The winds that circulate from dayside to nightside would be moving very fast, driven by the extreme temperature difference between the two hemispheres. There are no seasons here. There is no weather in the cyclical sense. There is only the permanent pressure of heat on one side and the permanent reaching of darkness on the other, and the long, continuous movement of gas between them. You might hear something in this imagined drifting. Wind, but not wind as we experience it. Not a moving of air between pressure systems. Not something that rises and falls with the turning of a world. This would be a constant flow, directionless seeming in the way that the current of a deep river seems directionless when you are inside it. You would be inside the movement. It would not feel like weather. It would feel more like the breathing of something very large. There is a strangeness to the idea of sound here. In such a dense and hot atmosphere, sound would propagate differently. Pressure waves would move through superheated hydrogen in ways that would make whatever sound existed feel lower, perhaps deeper, slower. But we are speculating, as we often must with these distant worlds. We are building pictures from limited information and our own sense of how physics works. And then we are looking at those pictures carefully, the way you might look at a room in low light and try to understand its shape from only the edges that you can make out. WASP-B was discovered in 2008. It was found using the transit method, the slight dimming of its star's light as it passes in front from our perspective. That dimming is measurable, faint, regular. Once per day, roughly, the light from WASP-12 dips very slightly. That small dimming has told us the planet's size, its orbit, its density, which is unusually low, suggesting it is being puffed up by the heat, bloated outward by the energy it constantly receives. It has no moon, as far as we know. If it ever did, the tidal forces that are pulling the planet itself apart would have long since made any moon's orbit unstable. There is something to sit with in that. The loneliness of this planet is not dramatic. It is simply factual. It orbits alone, close in the heat, gradually becoming part of the thing it orbits. The star will eventually consume what remains of it over millions of years, and by that time WASP-12 itself will be approaching the end of its own life, expanding as older stars do, brightening. Everything here is in slow, continuous transition. The planet is not dying in the way stories imagine planets dying. There is no collapse, no explosion, no sudden ending. There is only the long arithmetic of gravity and time working on gas, the same physics that governs the clouds over any quiet landscape on Earth, extended across scales and durations that make the word slow feel insufficient. Imagine you are drifting in the Terminator region one last time. The star is there, on the horizon that is not quite a horizon because there is no ground beneath you. The light is amber and white and very bright, but absorbed by everything around you before it can scatter into anything soft. The gas moves past you, carrying heat and trace metals, and the faint memory of whatever this planet was before it was so close to its star. Somewhere above you, beyond the clouds, the gas continues to flow outward toward WASP-12, too slow to see, too continuous to ignore. There is no sound but the wind, and the wind does not stop. The sky is dark on one side of you and bright on the other, and the line between them is where you are. And that line has been exactly here, exactly like this, for longer than our species has existed. It will remain here, roughly like this, for longer than we can reasonably imagine future things. The planet will change, is changing, but slowly enough that the word change feels borrowed from a faster world. This world has no seasons, no dawn, no weather that comes and then leaves. It has gradients. It has the permanent conversation between heat and dark, between a star's gravity and a planet's own slow resistance to being unmade. WASP-B is about 1,400 light-years from where you are. The light from its star that astronomers used to discover the planet left before many familiar things in human history began. It has been traveling through space for a long time, and when it arrived, it told us about a world that is disappearing into something larger than itself, quietly, across a timescale that makes quietness feel like the only appropriate response. Rest here for a moment if you like. There is no rush. The planet is still there, still drifting, still warm, still being slowly drawn toward the light it cannot escape and does not seem to be trying to. There is a planet that was already old when our sun first began to form. It orbits not one star but two, and those two stars are themselves orbiting a third point in the sky, a common center of gravity they share with a great many other stars, all of them old, all of them dim, all of them part of a globular cluster called M4. The planet is called PSRB 162026b, which is not a beautiful name, but it is an honest one. It is approximately 12,500 light-years from here. It is, as best we can measure, around 12.7 billion years old. For comparison, the universe itself is only about 13.8 billion years old. This planet formed when the universe was still young. Not young in the way we mean when we say a person is young, or even young in the way we mean when we say a civilization is young. Young in the sense that the first generations of stars had only just finished burning and dying, and the heavy elements scattered by those deaths were still settling, still finding one another, still learning how to clump and gather into something solid. This planet was there for all of that. It has been here for almost all of it. Imagine you are standing on its surface, or what its surface might be. We do not know precisely what you would find underfoot. The planet is large, several times the mass of Jupiter, and so it is almost certainly a gas giant, which means there may be no surface in the way we usually mean. But you can imagine yourself suspended somewhere in the upper atmosphere, drifting slowly, the way you might drift in still water just below the surface of a lake. The air around you is probably hydrogen and helium, cold and thin at the heights where you are, thicker and warmer somewhere far below. There may be clouds, though they would be unlike any clouds you know. Quiet layers of ammonia or water ice, perhaps, drifting in slow horizontal bands. Nothing urgent, nothing rushing. The light here is very faint. M4 is a globular cluster, a roughly spherical collection of hundreds of thousands of ancient stars, and they fill a region of sky that would appear to you as a soft, dense glow, something between a cloud and a constellation, too diffuse to cast shadows, too present to ignore. The individual stars within it are mostly old and cool, orange and red, the deep amber colors of a fire that has been burning for a very long time and is in no hurry to go out. There are two stars much closer to you than the rest. One of them is what remains of a star that died long ago, a pulsar, a neutron star spinning at a rate of about 100 times per second. It does not look like much from here. It is tiny, dense beyond easy description, and it emits beams of radiation that sweep through space like the beam of a lighthouse, though the beams are not light you could see with your eyes. It does not glow the way a normal star glows. It is more like a point of intense, concentrated stillness. From the distance of this planet, it might appear as nothing more than an unusually bright point in the sky, perhaps with a faint blue-white quality to it. The other star is a white dwarf, the cooling remnant of a star somewhat like our own sun, also long dead, also no longer burning in the traditional sense. It glows a pale white, fading slowly over billions of years. It is warm in the way that a stone is warm after the sun has set, holding onto heat that came from somewhere else, giving it back to the universe in no particular hurry. These two stars are close to one another, and they move around each other, and the planet moves around both of them together in a wide and leisurely orbit. The whole system is itself moving through M4, that ancient cluster, slowly drifting through a neighborhood of old stars. The sky around you, then, is not dark. It is populated, not the way a city is populated, loud and bright and crowded. More the way an old library is populated, full of presences that have been there a long time, each one still and quiet, each one carrying something. The cluster fills a significant portion of the sky, a soft haze of ancient light, deepening toward the center where the stars are more densely packed, fading at the edges. If you looked carefully, you might be able to resolve individual stars at the outskirts, each one a warm point of orange or yellow, each one telling you through its color alone that it has been burning for billions of years. There would be no darkness here the way we have darkness on Earth at night. There would be a kind of permanent, gentle twilight, a luminous dusk that never fully deepens into black. The cluster light is diffuse, soft, the kind of light that does not illuminate so much as it suggests. We do not know if there is wind here. Gas giants in our own solar system have winds, sometimes very fast, but their character is tied to the energy coming from their host stars and from the heat of their own interiors. This planet's two parent stars are both dead, both quietly fading. The planet itself has been cooling for billions of years. Any atmospheric circulation would be slow, sluggish, driven more by the long memory of heat than by any fresh energy arriving from outside. Imagine a very slow movement of air, something you could feel only if you held very still. A pressure from one direction, then a gradual shift to another. Not wind exactly, not weather exactly, but a kind of breathing, slow and deep. The planet's atmosphere adjusting to gradients of temperature so subtle they would take years to fully express themselves. Everything here is slow. Everything here is old. There is something that happens when you spend time with something very old, a kind of recalibration, a softening of urgency. You begin to understand your own impatience as a product of scale, a misunderstanding of the time available. This planet has been here for 12.7 billion years, and the universe that contains it has only been here for about 1 billion years longer. This planet was already ancient when the molecular cloud that would eventually become our sun was still just drifting gas, unorganized, not yet drawn together. It has been here through the formation of our solar system, which took roughly 100 million years to settle into its current shape. It has been here through the entirety of Earth's geological history, through every ocean and every extinction and every ice age, and every mountain range that rose and eroded and rose again. It has been here through all of recorded human history, which at its longest reaches back perhaps 10,000 years, a number so small compared to 12.7 billion that it does not meaningfully exist on the same scale. This planet does not know any of that. It is not watching. It is simply here as it has been, drifting slowly around two quiet dead stars in a cluster of ancient light, doing what planets do, which is mostly nothing, mostly just being present, mostly just continuing. The globular cluster M4 is visible from Earth with the naked eye, on a clear night in the right part of the sky. It appears as a faint smudge near the bright star Antares in the constellation Scorpius. People have been looking at it for a long time, though they did not always know what it was. Now we know it contains this planet, or we are quite sure it does. And that knowledge changes the smudge a little, gives it something to hold. But the smudge is still faint. It still looks like almost nothing. Out here, of course, it fills the sky. The pulsar at the center of this system does something the original stars never did. It sends out its sweeping beams of radio waves and high-energy radiation with extraordinary regularity, ticking like a clock, marking time in a way that no biological creature ever evolved to perceive or appreciate. It has been doing this for a very long time. It will continue doing it for a very long time more. The beams pass through the planet's atmosphere without incident, without leaving a mark. The planet does not notice. Perhaps that is the thing to hold on to, drifting here in the amber light of 1,000 ancient stars, in the atmosphere of a world older than our sun. Nothing here is urgent. Nothing here is waiting for anything. The pulsar ticks its invisible ticks. The white dwarf slowly cools, a process that will take longer than the current age of the universe to complete. The planet moves in its wide orbit, patient and enormous, carrying no message, expecting no arrival. The cluster light is very soft. It comes from every direction at once, almost, a warm and ancient glow. The accumulated light of stars that formed when the universe itself was just beginning to understand what stars were. You could rest here, suspended in that faint light, and the word rest would mean something different than it usually does. Not rest as in pause, not rest as in temporary stillness. Rest as in duration. Rest as in the way a stone rests at the bottom of a river, held there by nothing dramatic, simply settled, simply present, while the time moves past in one direction and the light comes from very far away. The cluster turns slowly overhead, if overhead means anything here. The two dead stars trace their quiet orbit. The planet continues. It was here before our sun. It will likely be here after our sun is gone. It will be here the way certain silences are here. Not empty, not waiting, simply occupying a space that nothing louder has managed to fill. The light is old and it is gentle, and it comes from a long way away. That is enough. That is more than enough. There are worlds we have not yet found. They are out there, turning slowly in the dark, around stars we have not looked at carefully enough, at distances our instruments have only begun to reach. Some of them are the size of this one. Some are smaller. Some are wrapped in oceans with no shore at all, or clouds that never part, or silence of a kind we have no word for yet. We have not found them, but we know, with the quiet certainty that comes from counting and measuring and reasoning slowly over many years, that they are there. Imagine you are drifting, not toward anything in particular, just drifting the way light drifts after the source has moved on. Around you there is the kind of dark that is not empty because it never is. Every point of it has something behind it, some star or some cold, dim remnant of a star if you only go far enough. You are not afraid. You are just here, in the interval between knowing and finding, and that interval has a texture to it, something like the feeling of a room just before sleep. There is a world somewhere, orbiting a star like the ones we have seen in this journey, where the day is long and the light is rose-colored, and the dust settles in layers you could run a finger through if you were there. We do not have its coordinates. We do not have its name. It does not need one to exist. It turns on its axis at some slow rate, and the terminator, that line between the lit side and the dark side, moves across its surface at a pace you could almost keep up with on foot. Somewhere on that surface there is a plane, and on that plane the wind does what wind does, which is to move without asking. There may be a world where the sky is a very pale green, not because of any particular drama, but simply because of the gases that gathered there over millions of years, settling into an atmosphere through processes that are patient beyond comprehension. Pale green, and above it the star, smaller than our sun appears to us, or larger, we cannot say. And below it the ground, which may be stone or may be something we would have to look at for a long time before we understood what to call it. You would stand there on that green-lit ground, and the quiet would be total, and the quiet would not feel like absence. Some of the worlds we have not yet found will turn out to be ordinary. That is not a disappointment. Ordinary, when applied to a world, means something almost too large to hold in mind. A place with weather, with geology, with the slow grinding of tectonic forces or the patient accumulation of sediment at the bottom of a sea. Ordinary means it is doing what worlds do, which is to endure. An ordinary, unfound world is still a world that has seen more sunrises than our history has words in it. There are almost certainly planets around the nearest stars that we have not detected yet, not because they are not there, but because finding small things at large distances requires a particular patience, and we are still learning how to be patient in that specific way. The nearest star system to our own, a few stars orbiting each other in a slow and ancient arrangement, may have more planets than we have confirmed. We think there is at least one. There may be others, smaller, quieter, further in or further out. Imagine one of them if you like. The sky there would be different from any sky in this journey, because you would have 2 stars, and sometimes 3 if the geometry allowed it, and the shadows would fall from more than one direction, and they would shift as the stars moved, and you would learn to read the time of day not from one sun crossing overhead, but from the angle between 2 lights and the color that results when they overlap. There is a kind of world that theorists have described in careful, measured papers, a world made almost entirely of water, where the ocean is not a feature of the surface but the substance of the planet itself, layer below layer. The water near the core compressed into forms of ice that do not exist anywhere on this planet. We have not found one of these for certain. We have candidates. We have data that is consistent with it. If you were above one, looking down through its atmosphere, there would be nothing but cloud, and below the cloud, ocean, and below the ocean, more ocean, going down and down into pressures and temperatures you could only describe in numbers, because the experience of them is not available to us. The surface of that ocean, though, the very top of it where light could reach, would be a color of blue or gray we do not have a name for, and the swells would move across it for thousands of miles without anything to interrupt them. No coast, no island, just water answering the pull of tides. Some worlds are tidally locked. We have visited one in this journey, that world of red and black, half burning and half frozen. But there are tidally locked worlds we have not found, around stars slightly warmer, where the terminator zone is not a border between extremes, but a place where the temperature is simply lower on one side and higher on the other. And in the middle there is something like afternoon, lasting forever. On a world like that, the clouds would gather in particular ways. The heat on the day side would push moisture up and outward, and some of it would condense and fall on the cooler parts. And there might be, in the permanent afternoon of the Terminator, a pattern of clouds and light and slow rain that repeated every day because every day was the same day. You would sit in that rain, which would be warm but not unpleasant, and you would watch the clouds move in their slow circuit, and you would not be waiting for anything, because there is nothing to wait for when time moves in a circle. The universe has been making planets for a very long time. The first rocky planets formed around the first stars, and those stars are gone now. but their planets, or whatever those planets became, may still exist somewhere, changed beyond recognition, cold, dense, wandering in the dark without a star to orbit. We call them rogue planets. We have found some evidence of them: dimmed light, slight bends in the path of photons from distant sources. They drift without any particular direction, having been flung out of their systems by gravitational interactions that no one witnessed, moving at whatever speed the fling gave them, which may be fast or slow, and they have been moving for longer than the Earth has existed. On a rogue planet, there is no day. There is only the very faint warmth of internal heat, if any remains, and above that, the sky, which is the whole sky, stars in every direction because there is nothing to block them, no sun to wash them out, no horizon except the one the planet itself makes. If there were something standing on that surface, which is a kind of imagining that requires patience with uncertainty, it would see more stars than we do from any place on Earth. The Milky Way would be a river of actual light overhead, not the suggestion of a river but the thing itself, and around it the darkness would contain galaxies visible to the eye, if the eye were sensitive enough, small smudges that are each 100 billion stars, and each of them impossibly far away. It would be very cold. It would be very still. We have found in the years of careful looking several thousand worlds beyond our solar system. Each of them was a signal before it was a world, a dip in a light curve, a wobble in a spectrum, a pattern in the data that repeated and repeated until the repetition itself became a kind of fact. We gave them names that are serial numbers because we did not yet know what else to call them. For every world we have found, there may be 10 we have not, or 100. The estimates vary, and the estimates are honest about varying. We know the number is large. We do not know exactly what large means in this context, except that it means more than we have seen, possibly more than we could see in a very long time of looking. And in all of that, the quiet is the same. The light from those worlds reaches us without making a sound. The motion of those worlds around their stars produces no noise that crosses the space between us. We infer them from the quietest of signals, a shadow, a color shift, a number that changes and then changes back. Distance makes everything quiet. Distance makes everything slow. There is something settling about that if you stay with it long enough. All those turning worlds, all that rock and gas and water and ice, all those skies of colors we have seen a few of and imagined many more. All of them doing what they do in complete silence from where we stand, not because nothing is happening there, but because the space between us is so large that even the loudest thing would arrive as nothing. We are not nothing to ourselves, but we are very small, and the dark between the stars is very wide, and inside that width there are worlds. They are there now while you are here. They were there before this journey began. They will be there after. The one we have not found, the one with the rose-colored dust, or the pale green sky, or the permanent afternoon where warm rain falls in a circle, is there now in the dark, turning. It does not need us to find it in order to be real. That is enough. Rest now.